So today I'm going to be talking about voltage. Before we get into any examples, first we have to know the basics. So the definition of voltage is the measure of the energy lost per charge between 2 points. So a voltage analogy, just to put it into perspective to make it a little easier to explain. For example, I start out by having $100 and go to 4 stores. At the first store, I spend $15. At the second store, I spend $45. At the third store, I spend $30. And at the fourth store, I spend $10. Out of all the money I spent at all 4 stores, I spent $100, which is equal to how much I originally started out having. This will cancel out, leaving me with $0 remaining. So there's a law called Kirchhoff's voltage law, and this basically just says that in any enclosed loop, the sum of the voltages must add up to 0, and the energy supplied must equal the energy used because of the conservation of energy. So whenever you make a loop where the resistors are, it has to add up to the overall voltage of the battery. So an example, let's say you have a overall total voltage of the battery that equals 20. So resistor A, which is right here, resistor B, resistor C, D, E, F, and G can all be used into different loops to talk about voltage. So our first step is to find all of the loops and then go from there. So the first loop that I made includes resistors A, B, D, E, and F. So since we said that the law for voltage has to add up and equal the whole voltage of the battery, in this case it's 20. So just to put numbers to make it easier and put it in perspective for you, I made resistor A 5, resistor B 5, resistor D 5, resistor E 3, and resistor F 2. I did that because each of the resistors, they might not share an equal amount, but after going through resistor A, it then goes and travels to B, D, E, and F, which then obviously has to equal 20 in the end. So when you add them up, they will equal 20, any loop that you create in this example. So 5 plus 5 is 10, plus 5 is 15, plus 3 plus 2 is 20. So that would be the equation voltage of A plus voltage of B plus voltage of D plus the voltage of E plus the voltage of F minus the voltage of the battery must equal 0. Another loop that can be made is this one right here, which includes resistors A, B, D, E, and G. So we're excluding F now. So as I said before, it must equal 20. So the whole entire loop must equal 20. So resistors A and B and D equal 15, then you add E and G, which then equals 20. So it works. So as I said, the voltage of A plus B plus D plus E plus G minus the voltage of the battery, which is 20, will then equal 0 because they cancel out. So another loop I made, just reiterating it, is it will include the resistors A, C, E, and F. So a little less than before, but still basically the same thing. So resistor A is 5, C is 10, which equals 15 when you add them, plus 3 plus 2, that will then equal 20, and then it will cancel out to equal 0, as said in this equation. Voltage of A plus voltage of C plus voltage of E plus voltage of F minus voltage of the battery equals 0. And This is our last loop that we can create, which is including resistors A, C, E, and G. And it's basically the same thing. So you would add 5 and 10, and then 3 and 2 from the other resistors, which then equal 20, minus the voltage of the battery, which equals 0. So that is how you find the voltage, and you use voltage in this one example.